So the objective here is to, as we have so many homework problems, is to reduce our time on task. The economies of scale example. So we might have some economics class takers out there, but anyway, here's your economies of scale. Let's use the StatCrunch to reduce our time on task. Alright, so what I'm going to do is build on this JRO video here. This one's about running summary stats. And we were talking about this last time, is not only can you use the graph to visualize what you have, shape. Let's look at this question. Anyway, I gotta clear my, that's why I couldn't see before. Anyway, now let's go to, I'm gonna go into StatCrunch, and by the way, I found this in these data sets that you can find, well, I'll back out and show you, but you can find these data sets, and notice the number that it referenced, and what it was this problem in the homework, 21225, and notice it is very similar to the, what did we have in our, did we have baseball? We had soccer and football, I can't remember, but anyway, this is very similar. So that's what I did. I looked up this number and I found the data set that goes with it. So this is, so we had an Olympic hockey team and soccer, and these data appear to be exactly the same. So I thought this came out of the textbook. I just wasn't sure where it was. A little rusty, as I had gone through this once before, right? A couple years ago. But anyway, let's take this, and that's what I want to do here is consider have we done dot plots? We did some of the dot plots in IXL, but let's go ahead and do this here. Let's go ahead and make a dot plot. Let's make one for the hockey. So there should be a way to get them both on there. Should be a way to get them both on there. And we got our point size. It looked like 5 was about right from the last time, so I'm going to go ahead and try that. Let's mark the mean and the median. So the mean is green and the median is red. Let's just say the green is mean because remember it's influenced by outliers, so it's got the green go 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 sign, and the median is resistant, so it's got the red stop stop stop. Is not going to get pulled in the direction of the skew like the mean is. All right, let's just leave that unchecked for now. We can label some stuff, but let's just see what's going to happen and what's going to get generated at this point. And there it is. And see, I like that because my previous graph I did last time, I either was not aware how to make those dots more visual. See that impact, by the way? And I think it tells you how to copy, like if you want to copy, you do something like that and you copy it and paste it into your Word document. That one turned out pretty good. That one turned out pretty good with the dot plots. So I think, you know, like, even once you get it made, you can edit it. You can go back and check what your grouping by that anyway, this gets what we needed there. And I think so. Like if I close this, see how that 1 shows up? So I should be able to go down and then hit results, and there you can see that was the task I just did. Okay, so I guess the question is, okay, notice the mean is slightly to the left, so we could say that we probably have a skew left, right? It goes in the mean is in the direction of the skew. See, there's the median, and then there's the mean. Not much of a difference, but there is a difference. And notice here, we would say this one's pretty much symmetric because the mean and they're just different by 0.5, so we pretty much got a symmetric one. Now one thing is, let's look at what it was always asking. The shape. The shape. Hockey team, when we had the soccer. The center. See now with that 1 dot plot we had, with this dot plot, we have a measure of the center. These measures of the center. And I went ahead and ran, this is the summary stats, and that's what I was wanting to show you. Basically, these are the ones really don't even need the variance at this point. The n, which is the total number in your sample, is good to have. We really don't need the standard error right now. We will, but we could probably not run that up, but we might want to go ahead and get used to running it. The only difference is don't confuse it with the standard deviation. These are done slightly different calculations. When we start getting into normal curves again, this will come in handy. All right. And then here we have basically our box plot, 5-number summary stuff over here. And so let's go with this and see if we can start to see shapes into. Now let's do another objective here. And I think, yeah, so go into stats, summary stats. Let's do the columns. Let's run both of these, see what happens. I usually grab, so you can use your control key to grab what you want. So I'm pushing down my control key. Let's get the mean, let's get the standard deviation. Let's round up our 5-number summary here. And the IQR. We don't really need any of this other stuff, but we might as well throw the mode in. These other ones, they have meaning, but not right now. So let's compute what we have right there, and then there you see the summary stats. I think that's interesting. In the hockey, it identifies multiple modes, so it's not bimodal, it's multiple modes, so there must be more than one occurring. That's in the hockey way. So let's sort this table from least to greatest, and when we're doing that, let's go ahead and close this. We should be able to find there, 219 is mode possibly, method occurring twice, 190 occurring twice, 200 twice. But anyway, you see it's got multiple modes. Once again, if I want to recover my summary stats, here we have, I notice it's divided by that. Alright, so we have these numbers, and we can see the difference between the mean and the median, right? We can see these things. We can see where the Q1s and everything. That brings up, while we're here, let's make a box plot. Should I get these side by side? I like them to be horizontal. Green is the mean, it's not resistance, so green means go, red means resistant, means stop. Okay. Somewhere in here, use fences to identify outliers. Let's go ahead and do that. We know how to do that by hand, but let's go ahead and let the computer do what we got to do here and compute it. And there we are. There we see them in box plot form. And remember, you could hover over. There's where your whisker is. No outliers. No outliers according to this analysis. The box plot fences. We didn't have any outliers. I think some of us thought there might be some outliers. Maybe I was looking at some different data. I think this is the second one. Whatever, it was a different problem. Anyway, let's get going. While we're here, I think let's do a histogram. And we will do them by height. We can start the bins. Let's let it figure out maybe what the bins would be. And then I'll show you something that's pretty interesting about a histogram. And that's when you start doing these bins. So let's mark it up as we would have here. I like to have the values over the bars. That shows the frequency right in the graph. Let's compute it. There we have it. That's the hockey. So then the soccer are right here. And if you're wanting to copy them, right, you just hit copy. It'll make an image over here, and then you can copy it and put it. I suppose that takes you to Pinterest. Looks like I don't know what I just opened. Anyway, so you can see the frequencies. So see, that must be where the modes are showing up, right? But notice it's what it has grouped. So when we're talking about a bin on these histograms, notice it starts at 180, and then if you look down here, you can see that interval, 180 to 185, right? That interval, 180 to 185. And see, then it picks up at 185, and then it goes to 190. So these bin widths are 10. Let's try to start the bins and see what happens. Let's start them at 180, which is what we already have. But let's make the width 5 this time. And we're going to see how this histogram changes. It changed slightly, but I should have taken a picture of what it was, right? But anyway, depending on the bins, widths would determine how it's going to look. So that's one thing about a histogram is, you just don't want to look at it. Let's even try like doing 2s and see what happens. And see that there, our histogram's starting to look a lot different. Now we're doing intervals of 2s. We can tell that we evidently have a gap of no observations between 184 and 186. Also a gap over here between 192 and 198 all the way. But anyway, you can see how changing those bins, the bins, those are the bins that collect up the histograms. I think I have, let's see if I did one old school. Well, maybe we'll just have to experience what the bins are. The bins. Well, let's take a look at this particular problem. See, like this was categorical data. Tobacco use, high blood glucose, physical activity, and overweight. We have those, and so those are categorical. So see, that's the frequency, counting those up, right? Counting those up. So in the same sense, that's what we're having going on here, and I lost track of what I was doing. But anyway, when you change those bins, right, the number that occur within that width, right there, is going to change, right? Because we change the width of which we're gathering. Those are why they're called the bins, right? The bins, B-I-Ns. Anyway, so notice once again, we have these results: a dot plot, a summary stats, box plot, and a histogram. So that should bring us all together, the types of things that we were looking at. Oh, I want to show you, like, when you're looking at these box plots, you can hover over, see there? You've got your 5-number summary values, you got your IQR, you got your Q1, there you go, you got it, right? Just hover over it, and then it'll show you data points, the lower limit, the upper limit, right? You got all these. You can extrapolate this data. The box plot, I think, tells us a lot. These different graphs are going to tell you different things, and it's one of those things, which one do I like to see when I start answering questions about shape, right? I like the box plots. When I don't know what the shape of the data is, it'll show me outliers and skewness. The dot plot's cool because it allows you to count up how many dots there are in there. I'm trying to determine oh, that's interesting. So here's the dot. It's 165. Oh, that's the soccer. So if that's 140. Oh, we didn't sort the soccer rates. That'll help. And there's the 140, right? Notice it's row 1. Here's 145, row 3. So that's not, notice this is the 145 row 2. So see, it's just going through these rows, and you can identify your points here. So see how you can get the essence of your graphs here. Anyway, that should complete our J row 10, or I forgot which one we were doing here. We were yes. This will be the J-Row video, typical run, StatCrunch, Summer Stats. And I went ahead and threw in some analysis from those graphs and StatCrunch that you can use there for whatever. I'm getting tired and I'm not connecting. But anyway, you can use that when you're asking your questions about shape, center, and spread. Alrighty, let's see if I can get this.